Sorry, I think I accidentally unmuted someone. But in the meantime, do you wanna talk a little bit about the repo while we wait for people?
Yes. So as part of the preparation for the talk, I was thinking how I can actually show up what Duckula does in the most concise way possible, with featuring more of the features and less about focusing on the request processing and so on. So the greeter is a very simple API. It's like a hello world. You send it a name and it will just respond back to you over HTTP. The point is that it does all the validation using the provided Avro schemas as explained in the talk, and also can optionally serve the API documentation generated from the Avro schemas and the API configurations. So it's like an example that shows all the features. If you poke around the project CLJ, you will see that the Swagger support comes from the unstable version of the library. That's because we just haven't released a new version just yet. But it is available on Clojure if you want to try it out. And yeah, it's more of a follow along repository that you can also use when looking at the slides and listening to the talk. And that's about it. It's very simple to set up. I made sure it still works. I found a bug just before the Q&A session started, so I'm going to push the bug fix sometime after the talk ends. But it's just a simple syntax error. Nothing major though. All of the functionality is still untouched. And that's about it. It's as simple as it gets.
So I have a question, I guess, while we wait for other people. Duckula focuses a lot on integration with Avro, right? And I think I remember seeing a discussion you guys had in the Slack recently. But just what were some of your decision-making criteria that you were taking into account when you were deciding to use Avro?
Yeah, so partially it does require some of the historical context where Duckula came about, and I kind of skipped over that in the talk. I didn't talk about it too much because it was sort of unrelated to what it does, and partially was also about the fact that we don't use Clojure exclusively. We have TypeScript and Ruby in the mix in our application, so that also guided our decision. So the historical part is that at some point, we were using Kafka for processing internal events generated by all the pieces of the application. And Kafka folks encourage you to not use JSON or something schemaless for producing messages and consuming them. And they advise to use Avro. So we picked that because it was like, okay, well, let's follow the guidelines. And somehow throughout the history, we actually removed Kafka. We settled back on using RabbitMQ and Postgres. We were using RabbitMQ pretty much from the day one, and we had to kind of keep using the Avro messages that we use for the event streams. So we just created the adapters in our own RabbitMQ library for publishing and consuming messages serialized in Avro. And then we noticed, well, this is kind of handy. We have all the validation. We don't have to mess around like with protocol buffers, recompiling them and use code generation. So we stuck with Avro for our RabbitMQ usage. For the most part, we still use JSON here and there. It's just a slower process to convert. And seeing the benefit of that, and also having the problem of unifying our HTTP processing layer, we kind of picked, well, Avro works for us already. Some parts of the service-to-service communication were also using Avro already to reduce the size of the payloads that were sent between the services. So we kind of decided to unify all of that and say, okay, from now on, whenever possible, we will use Avro as the serialization format when communicating between the services, whether it's asynchronous or synchronous communication. And then also, when possible, use the Avro just for validation when it comes to, communicating between components that not necessarily can speak Avro, like our TypeScript client, which is the front-end UI. doesn't support Avro just yet, so it has to use JSON, but we still get the same validation benefit. So it was ease of use, mix of reasons, and just the fact that the library that we ended up using for Avro support in Clojure is actually very good quality. It's been sort of unmaintained for the most part. In the last couple of years, we picked it up, we pushed some changes to it, and it's very easy to wrap your head around, as opposed to like other things I tried, like Thrift or protocol buffers. But it's a lot of also about the preference. I believe that all three just do the same thing, in a slightly different way. But Avro kind of being the most flexible and the easiest one to adopt kind of swayed us. And intrinsically, it's very popular in like big data usage patterns, which we don't do. So it's kind of ironic that we only use the serialization format and not of the integration with like Hadoop and Cassandra and whatever. All right, we have a question. So let me read it out. So in my talk, I mentioned twerp and how it's, which is a very similar RPC over JSON HTTP system. That came out of Twitch. I believe GitHub also uses it for some of its stuff. The blog post explaining and announcing twerp does a very good job of advocating RPC style APIs in the web. So the question is, what's the rationale for favoring RPC over popular REST style APIs and HATOS and stuff? So that comes from my background. So for the last 10 years or so, I've been just by chance, all the jobs I had and also includes Enjoy, always depended on working with external APIs, and those came every flavor imaginable. I worked with things that use good old SOAP web services, custom TCP protocols, and then REST, proper REST, which does content negotiation, has introspective APIs, everything gives you a link to a sub resource and so on. And then whatever works, which usually just falls down to let's just throw some JSON over HTTP and pretend that it's REST, but it's not. So what I noticed is that when consuming these APIs or building them, we always, the teams I was part of, we would always end up like bike shedding a lot, which, for those not familiar with the term, is just spending time discussing something that doesn't really matter, like the color of the shed for your bikes, right? The more important part is to have the shed to hide the bikes, and then you can discuss the color of it if it's really important. So we would always just waste time on discussions. Well, should this endpoint that updates someone's credit card be post or patch or put, and then what should be the name of the endpoint? Am I updating users when I update their credit card, or should I have a billing sub-resource? It always was just the conversation between getting the job done and how we get the job will always just take so much time. And because I haven't seen that many well-implemented REST APIs, I had the luck to work on one where it was properly by the book implementation of the proper REST as described in one of the initial papers and stuff. It just never worked. And as we were developing Enjoy, we just noticed the same. I just noticed the same pattern. So we said, okay, let's just not waste time on this. Let's just adopt the RPC style API because it just fits more our use case. When someone creates a document in Enjoy, they just create a document. That's the name of the endpoint. There's no ambiguity. When they want to tag it, they just send a sign tag and so on. So we modeled our APIs after the interactions of the users to like expose the business logic. So that then we don't have to think about how someone is going to call the API. And that lends itself to second part, which is I found that RPC style APIs just by design give you more observability in terms of mapping endpoints to the metrics that an application generates. Working on like RESTful-ish sort of systems, it was always very hard to see what is a slow endpoint because the parameters in the request paths can be dynamic. So then you have to have some code that kind of unfurls that and tells you, okay, post documents / subject, whatever, what are the metrics for that endpoint across the whole customer base? And if you have any parameters in that path, it kind of messes it up. So you have to have custom instrumentation that doesn't necessarily map to the routes, and it's just a mess. So I think RPCs are good approach for that kind of stuff, where you know more or less what your domain is, and you don't have those flexible querying capabilities. You just need to expose operations to the consumer. In our case, it's other services plus our front end, and it seems to work pretty well, having that rigid structure rather than being very flexible. So that's my take on it. I know there are some guidelines around like modeling REST APIs, but I haven't seen any of them being implemented that well in order to have this promised land where, in theory, you are supposed to just have one HTTP library that can consume any API because it uses REST. That just never happened.
And you mentioned like you compared REST API and RPC style API. Have you used at all GraphQL? And if so, do you have any thoughts on that?
Yeah, so I haven't used it in Anger, so that's a massive disclaimer. I never had to integrate with an API that actually used it. From my perspective, it's definitely an interesting idea, but it doesn't go against the RPC style approach at all. If I had to use GraphQL, which is something that we were discussing internally, we would just expose a query endpoint, which incidentally you just post a query to it. Like, there's not much change from what we do here. And then that would be purely a read path where the front end kind of decides what they can get out of the backend system, right? But then the rest operations, I would still expose an API such as the ones you can build with Duckula, because having read the documentation for GraphQL's mutations, I'm not sure if it's like a workable solution. It does look very hairy. It does conflate like the robust reading API with like changing things and trying to hide the operations that you do. So I don't see a GraphQL as let's say, I see GraphQL being more of an RPC style API than being closer to REST in that context. That said, the mutation part is like, definitely doesn't look appealing to me. Like I said, I don't have much experience with it, and frankly, as our team works with more and more APIs, integrating more products, like we haven't seen it in the wild. So for me, it's kind of a non-issue. I'm just waiting for that first one to show up, and we'll see what we'll be able to get out of it, and I might have a better opinion.
One thing I noticed in the greeter repo, and that I think I really liked, was even though it's a very simple example, like really it's just one endpoint, it's very little code you have to get going to just get a web server running, and you can easily see how you can add additional endpoints, handlers, stuff like that. And I think part of that comes from like the data-driven structure that you have. And it's been kind of a seeming trend in the Clojure community over the past few years to move more from like the macro-driven APIs to more data-driven APIs. Would you say that was something that that you guys had to consider when you were developing Duckula, or something that was in your mind?
Yeah, absolutely. Again, it's also from partially historical reasons. So I remember getting started with Clojure way before I actually had the chance to use it in production systems. That was, I don't remember what time it was. You have to use Ant to build it, so pretty long time ago. And around the time when the ecosystem kind of started blowing up, there was a lot of macro use. And one thing I noticed is that macros don't really compose well. So having something like def endpoints is fine when you read it as a DSL, but then reusing parts of that is nearly impossible, for the same reason why everybody's moving off positional arguments, sort of the fake keyword arguments, to just passing around maps. So just maps are more composable, and they're just data that can be passed around, changed between function calls, and so on. So for us, it was the same decision to like keep the config as data-driven as possible. It is possible now to actually define the schemas in line with the handler config. You don't have to load the Avro schemas from the file. So you can go even as far as having your whole with the schemas all in just one gigantic map. It's probably not the most readable, but it's possible. So that's one. The other part was we also learned that from building our RabbitMQ consumer publisher library, where all the consumer config is also data-driven. The only thing you have to pass to it is the handler function for the consumer. And that was also something that we learned while prototyping, building earlier versions of that library, that it was easier to just understand what a consumer is doing by having a config map versus, you know, having some sort of macro that produces a consumer with some magic functions. And I think the broader Clojure ecosystem also noticed that trend, as you pointed out. Like I've seen Onyx configurations, it looks amazing because it's just data, right? You configure data, process it with data. It's kind of cool. But simply, the only downside, I guess, is that sometimes the config validation gets very unwieldy, whereas macros are kind of linear. So they can validate themselves if you write them properly. So that's probably the only disadvantage. But I do feel like everybody embraced this Clojure just functions and data paradigm. I think for the greater benefit of everybody. It's just they just compose better, if anything. Anybody had to work on Storm, which was originally a Clojure application, you can see how defining all the spouts and whatever they were called, it was kind of clunky because they were using macros. Onyx kind of learned from that and went all the data-driven way, and it's easier to see what's happening. All right, we have a next question. Let me just quickly go through it. It's a wall of text. So in your recent interview on the REPL podcast, you talked about the common library utility build you have. I think you alluded to how much provisioning and lifecycle apart from your services. Maybe it would be interesting to box here too. My experience on Microsoft services system, I either had a monorepo and had commons module somewhere, which grows and slowly become a bottleneck because it does way too much. In Java projects anyway, never been there with Clojure, or a multi-repo setup and a dependency build CI management nightmare because lack of tooling and automation. How do you manage this piece of your software? What is its lifecycle compared to actual services? Wow, this is a really cool question because it kind of alludes to Duckula in a way. So we used to have our own kitchen sink library that does it all. It's called Robin. That's because we call all the services and libraries after superheroes. So Robin is a sidekick, helps everybody. So you get the idea. So Robin did everything. It had a HTTP layer, which was kind of the basis of Duckula. It had a simple RabbitMQ library baked into it, data conversions, a lot of stuff. Like there was just a lot of stuff in it, and it kept growing. And because it was the early days, we also kept changing it quite often. So the life cycle of developing the library and having 10 plus services depending on it and catching up on all the changes was just unsustainable for us. So we deprecated it, I think a year or 2 years ago, and effectively started extracting the useful bits of it so they can be developed independently of the services. So this is basically where our RabbitMQ library came about. That's what utility build is. It's like extracted parts of Robin and just being like as small as possible, not too big, but still worthy of being like a single unit that can be pushed independently and pulled in independently by each service. We do have a multi-repo setup, and we just accepted one fact of life, which is things will get behind. So whenever a new version of, let's say, Duckula or utility build comes out, it's not like somebody goes and updates all the services that depend on them. We just say, okay, whenever someone gets around to working on that service, that's when we update the dependencies first, and then we do the actual work. It's just unsustainable to do it at all times, especially for some of the older services that just work. We don't have to touch them, so they can depend on the older versions of the dependencies. But this kitchen sink problem is absolutely real. I've seen it in Ruby, I've seen it in Go, I've seen it in Clojure as well, or as the original author of the question asked, like in Java as well. It's totally fine. So we basically treat our libraries like our services. We only touch them when we have to, and then if there are any dependencies, we synchronize the changes on as needed basis. And I guess that's a testament to Clojure kind of itself. We kind of developed our own internal ecosystem of libraries in the same way that the community does, where everything's very, very stable. We do rarely push out breaking changes to our own libraries as well, because it's just so easy to maintain backwards compatibility. And that's how we manage it. We kind of have a dream of merging all the repositories into a monorepo, but not because of the libraries and dependencies. It's more about change spanning multiple services, like adding a new feature to the front end and some backing services. It would be great to just have that as a single pull request, but at the same time, it's not like we are suffering that much from it, but it has nothing to do with the dependency management. So if there would be one advice from my side, is I would actually not worry about making sure that everything is always up to date, unless it has to, and just leave things to run on older version of your internal, and only catch up when it's needed. And that kind of brings the sanity to the whole delivery process. Also, all of the utility build is open source. It's up on GitHub, so you can poke around into like how we do SQL and how our I don't know what else we have there. There's some HTTP layer stuff that's open source. That's part of Duckula as well. We have some validation data conversions for Postgres and so on. So we've been successfully pushing it all out in the open, because there's just no point on sitting on it where other people can either use them straight up or just learn how to do some things. Same goes for like Avro support and so on. All of it is open source as well. Oh, please ask the questions here. I'm happy to talk about them. It's all related. All right, any other questions, or do I need to clarify anything from the talk or from my past answers?
I'm actually kind of curious about, so you mentioned you guys were thinking about moving over to a monorepo. Mm-hmm. And I've seen a couple on open source ones, like I think Rated is kind of a monorepo where there's like different modules, and they're all kind of independent, but it's all within one repository. Anyways, do you guys have like a strategy in mind if you were to do that kind of thing? Like, is there a certain approach you would take? I know there's like a plugin lane mono. Mm-hmm. Have you looked at that or something else?
So again, one thing that kind of doesn't help us is the fact that we have more than one language to worry about. So we also have TypeScript and Ruby in the mix. So some things like lane mono wouldn't really help us. And the way we are thinking about this, we are still sitting on the fence, because we have a funny name repository, because it's called Voltron. For those that don't remember, it was a robot that's composed of other robots, right? So that's like our model repo at this point. It just pulls everything else as Git submodules. We don't work in that repository. It's just a continued way of getting everything that you need to work on code. And we use that kind of model scenarios. Okay, if we had a monorepo, how we would use it. And first thing that fell out is like, we do not really see the need of rebuilding everything if our dependency changes, as I mentioned earlier. It was mostly for making cross-project changes more unified as one pull request, because then you can just check out one commit and get the state of the whole system as it was at that time. That's the only benefit we see, because we do have tiny bit of inter-service communication going on, to the point where sometimes implementing a feature might touch 3 or 4 repositories, and that's where we feel the pain. With like, there's a 4 pull requests to review and kind of understanding what there are dependencies between them. So that's what made us think about the mono repository, and we see that we solution to that problem. But then that brings a lot of challenges with it. For example, how do we run tests for only the service that change on a commit by commit basis? We will have to write some tooling that detects, okay, well, I don't know, we have a service called Doombot, which serves the Slack bot. We know that the code changed there. How do we reliably run tests only in that project and not run the whole test suite for everything? Like, there's no good tooling for that. We'll have to like write it ourselves. I haven't found anything. And then the other part is like cloning repositories that are updating them brings a lot of changes that we don't really care about. So you have to keep syncing with the main branch, and there's more cons at the moment than pros for a monorepo. So we are still thinking about it. The only one strategy for us to like merge it would be just convert our Git submodule repository into just one. There's a Git command for it. It can merge all the history into the main repository's history. But again, we are not like super convinced that this is the best solution at this point, especially that we would not get any benefits from like the dependency management.
Yeah, that makes a lot of sense, especially when you have so many languages.
Yeah, one thing that we do to combat this many pull request problem is that we make all the changes backwards compatible so that we can roll out, for example, we have 4 services to update for whatever reason because they're tied to one feature. So we work in the way that we can independently deploy earliest work. So let's say there's something that adds a new database table that will be then exposed as an API. We roll that forward. It's live in the system. We know that it works while the other work kind of carries over, so that at the end of delivering the feature, we do not deploy like 5 things at the same time. Okay? We just adopted the strategy of like releasing as early as possible, so that then the last thing that usually goes out is just the front end that enables the feature to our customers rather than having these big bang releases. So we got pretty good at it to the point where we do like 20 releases a day at peak, or it doesn't really matter, you know, what's up on production, because we know that we are controlling like the delivery chain. All right, so we have another question. So Clojure is a library providing a locking mechanism based on Postgres advisory locks. I see in the repo that you talk about how the lock is released intentionally, manually, or automatically in case of a VM crash or a failure. I'm interested in the second case. If the VM crash, Postgres will release the lock because the session is closed because of a time limit. Am I right? What about the handler function that's supposed to be running while holding the lock is long, or the Postgres thread is blocked, or there's a GC pause? Wouldn't the session timeout too and the lock be released by Postgres grabbed by another server while the first one is just slow and eventually continue its execution thinking it still has the lock? Wow, okay, so a lot of things to unpack. So thank you for the question. So Clojure is something that I described. I have a blog post about how we solve the problem of synchronizing execution, exclusive execution in our distributed system that we built. We have multiple services that can be scaled independently, and we run what we call the schedulers, which is at a fixed interval, we have to do something, pull an API, roll up some data, store it in a temporary table, instrument our data processing pipeline, which is not real time, it just batches the jobs and so on. So for a long time, what we did, we just hard coded. We would designate that one of the out of, let's say, 5 instances of a service would be the dedicated scheduler and orchestrate everything else. So, but that of course has a problem. If that instance, for whatever reason, stops, gets restarted, whatever, and doesn't come back, we lose the scheduler runner. So Clojure is very, very simple. It just uses the advisory locks from Postgres, where we issue a query at the start of the scheduler, and multiple candidates try to acquire the lock. Only one of them gets that lock and holds it for the duration of the PostgreSQL connection session. So the main question is like, what happens if the lock holder fails? And the reasons for the failure can be different. So the classic distributed systems problem is like, how do we know is it slow or is it down? We don't know that. So our solution to that is that all the scheduler functions, the handlers, their only job is to acquire the lock, get the necessary data for doing the work, and then they push to the RabbitMQ queue. So what happens is that the scheduler runs that are usually less than 500 milliseconds. So we actually do not do any work in the scheduler itself. The only thing we do is to just make sure that there's only one instance of a job being pushed to be picked up by a consumer in RabbitMQ, and then this way we guarantee that we do not lock things for too long, so that we can get into that weird state. And that's been mandated basically from the beginning, since we actually had the scheduler set up in our Clojure services. So we push the problem somewhere else, and because we use exclusive consumers in RabbitMQ and we have durable queues, we know that once the job gets pushed to the queue, we kind of know what the state of it is. It can retry itself without disrupting the locking. So that's how we combat it. And it's been pretty effective for almost a year now. And that's more or less how the system even worked before we had Clojure as well.
Awesome. Well, thank you, Łukasz. I think that's all the time we have for your Q&A session, but I think it was really interesting to hear about how you guys are dealing with these large-scale distributed problems.
Thank you. Well, I'll be on Slack so I can answer any other questions in there. And yeah, it was a pleasure. I hope everybody enjoyed this Q&A session and also the talk.